Hi. In the next 2 weeks, students will be able to understand the properties of solutions, solubility, and the stoichiometry of reactions in solutions. As you accomplish all the readings and activities, you are expected to use different ways of expressing concentrations of solutions, which will focus on molality, describe the effects of concentration on the colligative properties, and calculate boiling point elevation and freezing point depression from the concentration of a solute in a solution. And at the end of this module, you are expected to search a problem set involving molality, boiling point, elevation, and freezing point depression that has practical applications. Read and understand the directions and follow for you to be able to get the highest possible scores. So, for the directions, find two sample problems for each topic. So, that will be molality, boiling point elevation, and freezing point depression. Present it in GRESA method. Show the given, required, equation, solution, and answer. And then, write 5 to 10 sentences explaining the practical application of your sample problem. And then, you may use the last page of this module or write it in a separate paper and attach it with your other activity. And then, practice orderliness, cleanliness, and avoid erasures. Activity 1 is a review of how to get the moles in a given problem. And then readings 1 is about concentration units, which will talk about molality, and then solubility and properties of solutions. And then I gave an example for expressing a solution, in various units. So this example will focus on molality. As you observe, this is the same problem from your module 2. Mass percent and then mole fraction of ethanol. And then letter C will be about molality. Okay, so another way of expressing solutions is by molality. This molality will be used for the next topic of our module. So, I go straight to letter C of your example, which required the mass percent and the mole fraction of ethanol. So, solving for molality, you will need a moles of solute and kilogram of solvent. So, these values are already solved in part B of your example. So, solute will be the ethanol, which has a 0.171 mole. Solvent will be water, which is 90.3 grams. Both came from part B. So, first step is to convert the mass of solvent, which is 90.3 grams, to kilogram, since kilogram is the requirement for molality. So, 1,000 grams, 1 kilogram. So, this will be cancelled. So, divided 0.0903 kilogram of water. So you now have your kilogram of solvent and you have your moles of solute. So now, substitute the values to the formulas of molality. So moles of solute divided by kilogram of solvent. your molality will be 1.89 m of ethanol. That's all. So, activity 2. So, understand and follow the examples given, and to have a visual understanding of this problem, you may check this link to read about the sodium bromide. And so with this problem, for you to have a visual understanding of glycerol. Readings 2 is about properties of solutions, and then it will focus on colligative properties. And in under colligative properties, you have 4, but we will focus on 2 colligative properties, which is lowering of the freezing point and an elevation in the boiling point. Read and understand and take note of the formulas given, and these are the freezing point, depression, and boiling point elevation constants. Then an example is given. So going to the next topic, which is colligative properties, let's take a look at the given example. So in the given example, nicotine extracted from tobacco leaves is a liquid completely miscible with water at temperatures below 60 degrees Celsius. First required is what is the molality. As mentioned earlier, molality will play a part in this topic. Molality of nicotine, and then next is what is the molar mass of nicotine. Assuming we don't know the chemical formula for nicotine. These are the given. So, EF of solvent, which is equal to negative 40. EF of solvent, which is equal to negative 0.450 degrees Celsius. Mass of nicotine, which is 1.921 grams. And mass of water, 48.92 grams. And then, the required will be molality of nicotine and the molar mass of nicotine. As mentioned in your reading, historically, chemists use the colligative properties to look for the molality of a certain, to look for the molar mass of a certain compound. Equations to be used are formula for freezing point depression, which is delta TF is equal to KF, which is a constant, and M for the molality. Where, please correct this in your module, delta TF is equal to TF of pure solvent minus TF of solution. And the molality, which is moles of solute over kilogram of solvent, and number of moles is equal to mass times the molar mass. For letter A, so let's first solve for, or let me show you how this delta TF was solved. Delta TF equal to TF of solvent or solution. TF of solvent is 0.450 degrees Celsius. Negative minus TF of solution, as mentioned in the problem, it is an aqueous solution. Freezing point of water is 0.00. We now have your delta TF as negative Celsius. So, we have our TF, and then KF is already given in the table, which is we use the
freezing point depression constant of water, since as mentioned in the problem, it is an aqueous solution. Kf is 1.3 Celsius per molarity. Next formula to use is delta Kf is equal to Km times molarity. We are looking for molarity. Let's derive for molarity. Divide both sides by constant. This will cancel. Delta Dm is equal to delta Df divided by Kf is equal to molarity. Substituting the values, it is 0.4 degrees Celsius divided by Kf, which is 1.86 degrees Celsius over M. We will now have 0.242 M. That will be your answer for letter A. Let's start with writing the formula of molarity. You have your value of molarity, which is 0.242 moles per kilogram. Moles of solute, you only have the mass of solute, which is nicotine. So, to get the number of moles of solute, you will use this formula, which is mass times molar mass, which is our unknown. Mass, which is 1.921 grams, over our designation here is capital M, only for this problem, divided by kilogram of solvent, which you have in grams, so divided by 1,000 grams kilogram, which is 0.048 kilogram. This now will be our working formula. So let us cross multiply. This M will be part of your denominator. Grams. This will cancel. Get the value of M. We will divide both sides by this value. M now will be equal to 1.91 grams per Your molar mass now will have a value of 162 grams per mole.
Activity 3 is an application of what you have learned from the previous reading. So let's calculate. Then activity 4 will be apply your knowledge, which will be about the let's prepare part or your problem set. Again, two problems each topic, which is molality, boiling point elevation, and freezing point depression. For inquiries, clarifications, please message me. Thank you.